Welcome. Let's compare and understand natural exponential growth and natural exponential decay. On the left, here we have the equation that we use to represent a natural exponential growth. And on the right, here we have the equation that we use to represent a natural exponential decay. The way that we can distinguish between them two is by the sign of the exponent. If the exponent is positive, then we have a natural exponential growth. If the exponent is negative, then we have a natural exponential decay. One thing that they both have in common is that we are using the Euler number as the base. And just a small reminder, the Euler number, it's approximately 2.71. And the value of a in our equations represents the y-intercept in our exponential. And all this information, it's in our graph. When our exponent is positive, then our exponential is increasing. And we have a y-intercept at a specific location at the value of a. So we can represent this as a coordinate point at 0, a. And on the right-hand side, we have a natural exponential function with a negative exponent. Then that is reflected as a decreasing exponential. And the y-intercept, it is located at the value of a. We can represent that with a coordinate point at 0, a. And we can say that a natural exponential growth increases faster when we increase the value of a. The value of the location of the y-intercept. And we say that a natural exponential decay decreases faster also when we increase the value of a. The value of the y-intercept. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.